And I know you want to share with all of our wonderful viewers here today about one of our team members, one of our sponsors, who's really up the ante, as they say.
Yeah. So great shout out and kudos to Bell for having been a longtime supporter and sponsor, et cetera. In particular, Bob Hastings,
Mhm.
their EVP, good and great friend, who is a past recipient of the Magellan
That's
Award,
right.
right? And is a great public servant, served in the military, continued to serve after, et cetera. That's their culture. Bell
Mhm.
has great leaders. Both they're both innovative, et cetera, but they're also great corporate citizens. So I want to shout out to them. We'd like to, they've done some great work in technologies. Of course, they're known for VTOL, vertical
Mhm.
takeoff and landing,
Mhm.
and in particular, they've got their V280 Valor program, which is really exciting and interesting. And so, what I'd like to do is turn it over to our friends at Bell and have them talk. They've got a little panel, have them talk about that program, and I think our viewers will find it really interesting.
Great. Look forward to it.
Welcome. My name is Ryan Anger. I'm the Vice President and Program Director for Bell's Future Long Range Assault Aircraft, the V280 Valor. I want to thank AUSA Global Force Next for providing us this opportunity to talk a little bit about modernization, and in particular, the importance of the Future Long Range Assault Aircraft, and at Bell, what we've done with the V280 Valor to help transform and provide transformational capability to the Army. With me today, we've got a panel of team members from the V280 Valor team, and I'd like us to introduce ourselves, if we please.
I'm Craig Dupuy. I work on the Integrated Product Support team. Work in sustainability, just left the Army about a year ago to join the team, and 23 year or so Army aviator prior to.
I'm Becky Stiles. I'm Director of Vehicle Systems. It's comprised of avionics, electrical, mechanical systems, flight controls, and the systems integration labs. I have been a part of Bell for 18 years.
I'm Don Grove. I'm the lead test pilot for the V280 and Bell's chief tilt rotor test pilot. I've been on the program since 2014 and been with Bell since 2013, having retired from the Air Force as a test pilot on H-860G Payhawk and CV-22 Osprey.
Thanks, Tom.
Frank Lazara. I'm the Director of Sales and Strategy for Future Long Range Assault Aircraft. I too retired almost 5 years ago now. I had 7 years as an Army aviator flying scouts. Went over and commissioned in the Air Force flying MH-53 Pavlo, followed by the last 12 years of my career flying CV-22s. Came to this company and this program because I have a deep love for the tilt rotor, so I'm really glad to be here.
Thanks, Frank. For myself, I have an engineering background, started with the V280 Valor program in 2013, and have had the pleasure of working with a great group of professionals and seeing the V280 Valor go from clean sheet design to a flying aircraft that's demonstrated all of the Bell key performance parameters. So I think everyone wants to hear first from our test pilot, what's it like to fly the V280 Valor?
Well, whenever I get asked that, I can simply say it's just such a fun aircraft to fly. That's always what I come back to. It really is. And not only is it fun, but its performance has just been outstanding. It's completely impressed me how we've continued to move the ball down the field so continuously for over 3 years of flight testing. So the fact that the aircraft has done everything that we've asked it to do and more has been so impressive, and it's just a real honor to be part of the team.
So you've got V-22 experience and V-280 experience. Any differences in those platforms as a test pilot?
There are differences. I tend to look at the V-22 more like a truck and the V-280 more like a sports car. It's just extremely agile, much more maneuverable. It's built that way. Mm-hmm. It's designed that way, and it performs that way as well. A lot of the way it flies is very similar. Speeds are very similar. Mechanics to the pilot are relatively similar, but it's a completely different mission, and it's very specialized and very good at what it does.
And Frank, you've got some operational experience with the CV-22. How do you see some of the differences in the design of the V-280 as it pertains to operational effectiveness for the Army assault mission?
Well, the fact that it's purpose-built for the Army assault mission is a big discriminator. And that also drove, so when I got here, and I loved flying the CV-22 and had just a wonderful career doing that. And when I saw the changes in the V-280, whether they were specifically to accommodate satisfying what we thought would be the needs of the Army or not. They were just brilliant changes to the design, and some of the benefits of designing an aircraft for a mission, and the fallout of that was there's actually reduced complexity in certain areas. That's just a tremendous gain. V-22, phenomenal capability. I'd argue it's very agile. It is a larger aircraft and a heavier aircraft. But it is, the things you can do with it, whether it's at low speed or high speed. Now you take an aircraft with basically the same power system, give or take a little, smaller aircraft. The fact that so much is applied at point of design, and I'd like to draw attention to the fact that that is not just performance of the aircraft or the weapon system. It is accommodations for, you don't get to fly unless the maintainers keep the aircraft flying, and making that as simple as possible. Designing the aircraft with that in mind is a critical consideration. The rate of technological change, designing an aircraft to keep up with the rate of technological change through things like MOSA or Common Open Access Digital Backbone, it's going to be a game changer.
So we started flying the aircraft in December of 2017. We've gotten over 3 years of flight test experience. We've gotten over 200 hours of flying on the aircraft. We've gone over 300 knots. We've demonstrated level 1 attitude quickness. We've done some other neat things too. Can you talk about sling load or the fast rope deployment that we've done and how that was?
Sure, we wanted to demonstrate some of the mission capability that it has. And like we do all the testing, we took a very deliberate approach, a very safety conscious approach to it. We think this is what's going to happen, but we need to take this approach to prove it. So fast rope is a good example. We had several different sizes and weights of rope, used different hover heights to demonstrate the capabilities. And what we found is it's a very capable aircraft from a fast rope standpoint. Same with sling load. It was a very narrow test, very limited test. We demonstrated that we can do it, and it performed flawlessly in both those missions.
Mm-hmm. And is that something you've done with the V-22 as well, sling load operations?
Yes. Yep.
So Frank mentioned, so we talked a little bit about the air vehicle and how important it is to have range and speed, particularly as a deterrent for some future conflicts or to avoid future conflicts. The air vehicle is important, but in order to transform and provide transformational capability, we've got to talk about sustainment and we've got to talk about MOSA as well. So Craig, could you talk a little bit about what we've done differently in terms of designing the aircraft for sustainment and a different sustainment approach that we think will be more readily fielded and able to service the V-280?
Absolutely. So I think the first thing is that we've involved maintainer perspective at the very beginning. We take that to heart, and we have to make sure the aircraft is accessible, that we put in systems that reduce maintainer burden, that we improve the sustainment process and the supply chain to support that warfighter, especially in austere environments, separated from its maintenance or log tail, which really adds survivability to the maintenance side as well as what's provided by the aircraft.
So we've got over 500,000 flight hours on V-22, capturing a lot of lessons learned that have been rolled into the design. Have you seen that come to fruition, Craig, in terms of how we optimize this aircraft for sustainment and reliability and maintainability?
Absolutely. So just the design changes in the aircraft alone, reduce complexity in components, reduce moving parts, taking all that to heart. I came a little bit later in the game from when those things occurred, but it's very easy to see the impact. We're able to see the improvements in the high cost driver areas and what we've done to drive that cost down. And we continue to do that. We continue to work with the engineers to bring that maintainer reliability perspective in, and they're actively trying to make that better each day. And I think we've seen vast improvement to this point, and we're going to continue to exceed.
Thanks, Craig.
Yes, sir.
So Becky, what about the modular open systems approach? How does that fit into the V-280, and how does that provide additional capabilities for the Army going forward?
So I think it's important to remember that MOSA is not just even on the air vehicle. It's very important to the air vehicle, but dovetailing off of what Craig said, it's throughout the entire weapon system. So the sustainment team has been extremely proactive in ensuring the data is open. There are no clog points as parts are ordered, which allows the system, as we move on to the air vehicle and make it more configurable, easier to upgrade at the pace of technology, which we know is increasing. But on the air vehicle itself, building in up front this common open architecture digital backbone. We are, as an OEM, we have run into this situation ourselves many times on the commercial and the military side of looking at what's new out there and understanding our customer could really benefit from that. But seeing the logistics, the cost from regression testing, seeing that tail that falls behind it, and just the timelines associated. So we are extremely committed to building in the data, the electrical, the thermal, up front to allow for configurability to happen, and starting to demonstrate that on the JMRTD program, and incorporating the PDAS and the TCDL to show that we can do this.
Yeah, thanks, Becky. Just for a little bit of history, as I mentioned before, we started in 2013 with a clean sheet design. It was a design we wanted to put out there to demonstrate that we could have an Army assault tilt rotor. And so as we worked through that clean sheet design, all in the digital thread or in the digital enterprise, we paid special attention to things like having non-rotating engines, having large sliding side doors for the cabin for ingress and egress, having 360-degree operational safety around the aircraft with no propeller, no tail rotor in the back. But we also stepped through a very methodical approach between that clean sheet and getting to first flight. And Don, you've been on the program a long time, so you got to see that and watch as the engineering team worked with the pilot community and the flight test community and the component test community to ensure the proper maturation and risk reduction occurred up until first flight. So one of the important things that we did drive systems bench testing, we did rotor fatigue testing, but we also did a lot of systems integration lab work. And I wonder, Becky, if you can tell us a little bit about what a systems integration lab is and why that's so critical, not just to get to first flight safely, but to get to the second and the third and the fourth, and to ensure frequency of software drops are rapid and meet the needs of the pilots and the operators.
Yeah, well, first of all, we are extremely proud of our systems integration labs. They are an engineer's dream come true.
And a pilot.
And a pilot's dream
Yeah,
come true, so I'm
absolutely.
really happy to hear that. Within those labs, we have benches with representative aircraft wiring runs. Sometimes it's those latencies that come up and bite you, and you don't see them in the labs. So in there, we have everything from the real hydraulic actuators, we have the real flight control computers, the displays, that all tie into the cockpit rig. So Don and the air crew can then go fly the test card, the test mission. They can provide direct feedback to the engineering team immediately. And we can go off and do, within configuration control, the changes we need to make. Moving forward into the program, we'll start incorporating the digital backbone. We'll start incorporating the mission systems, the classified elements, and being able to tie those all together and drive out risk allows us to actually drive it to the aircraft faster. We don't have to go the fix and fly. We're able to do it all in the lab with Don and his team right there saying, this doesn't feel right, or we're good to go, let's roll.
Yeah. Let me piggyback on that. It is a real asset for us as the pilot. So we've used the SIL, Systems Integration Lab, for testing the new software, testing the hardware in the loop. We use it for training. We used it extensively for training ourselves before getting in the aircraft, and we also use it for the rehearsal, the mission rehearsal. Every single card we fly in the aircraft, we fly in the SIL first, and we've learned so much through all those processes, whether it's finding an issue with software that has to go back and get tweaked. We practice emergency procedures, and we change our emergency procedures based on rehearsing them in the systems integration lab. We go through the cards and we tweak our procedures, what we're going to fly based on what we learned there. So it's just been a tremendous asset for us, and it has saved a lot of time, a lot of money, and a lot of anxiety.
I'd like to add one note to that as well. Is we're learning lessons on our side in areas such as training, and looking to use the same concept, the same MOSA-like architecture or digital backbone within training systems, another cost driver for the Army, in TechPub data, and that allows us to provide rapid concurrency. We want to maintain concurrency with the aircraft at lower cost, really get away from 2 years to update a simulator down to doing that drop at the same time as the aircraft are. So we're learning from those lessons early and trying to provide that capability as well.
I guess I want to say that the engineering teams are listening. So they want to, as we're designing this aircraft, Craig's team is fully embedded with ours and taking that input and learning to think past first flight. We need to sustain this aircraft for decades to come.
Yeah, I think that's really evident when we do soldier touch points or we have visitors come. We don't just park our aircraft there and say, hey, go look at it, tell us what you think. It's really nice. There's clear evidence of the comprehensive approach that we've taken, understanding from the user perspective what it takes to take something into your formations, maintain it, manage it, and then use it to support the warfighter, because it's a supporting tool. And we could just say, hey, it's awesome, look at it. I mean, it's just fantastic, but we don't do that. And the deep thought that goes in, the fact that maintainers can impact design points on an aircraft, where in the old days, it was design built, off of a drawing, here it is, it runs out the other side, and you start figuring out what you got and what it's going to take to keep it in the air. And so much is done at the point of design now. It's going to make a huge difference when it gets out there.
Yeah, no, just to echo on to the soldier touch points, I mean, those are so valuable for us because it does provide harsh criticism. And that harsh criticism's so important early. And, we do take that to heart. And those have been incorporated. We learn those lessons. And we're able, the real good part about that is those lessons that we do learn, when we bring them back to the engineering teams, they're accepted. They're built in. There's a willingness there to get it better, which is it's very good for us. It's a good feeling to be part of that it's actually baked in and at the early stages.
No, thanks, Craig. So we've talked a little bit about the weapons system. I want to shift back, if we can, to modernization in general. So Frank, can you talk a little bit about why is modernization important? Why is FLRAA important to modernization? And then why the V280?
Yeah, so the easiest, lowest hanging fruit for a modernization example is the phone you're carrying in your pocket and the capability that phone has and gives you. Whether you like it or not, it is real. Let's go back 40 years and create some alignment with that example versus the weapon systems that we're talking about. If you tried to do today into the future, given I'll say observed threat, the continuous great power competition that we're going to live under for the rest of our lives for sure, and our children's lives as well, the number one thing you need is credible deterrence. If you are not constantly creating capability, upgrading capability, developing huge technological advances to feed that overall solution of credible deterrence to keep us out of conflict. We want to stay out of conflict. You can't do that by hanging on to the thing that worked 20 or 30 years ago, or even is working today. That's probably not going to work 20 or 30 years from now. It's really very simple if you look at it through that lens. Even the phone in your pocket 10 years ago didn't do half of what it does today. And there are business models, there are personal, life, organizational skills, all those things that people cannot do without their phones anymore. Right or wrong, that advance in technology now, on an exponential path, that transfers over to defense. And if you want to, keep the world from being in conflict, you need to make sure that everybody around knows that if you enter into conflict with us, we have the capability, and we've continued to modernize and keep our stuff in order, that it's going to be a bad decision.
So how does FLRAA affect modernization? We talked a little bit about the analogy about the phones, and that was very pertinent. FLRAA does something a little bit different for the Army than the enduring fleet.
There are a lot of things in there, and so I'll go down a particular path. When we talk about reach, range and speed enabling reach, range at speed, range at efficient speed, efficient performance, all those things are enablers. Now, you look at an assault aircraft and you don't immediately say lethal, but if you think about what the job of that crew and that aircraft are, and that's to take, in this case, soldiers to the point where they have to execute their mission, it increases lethality for the Army. It enables them to go ahead and prosecute their mission, but do it from standoff ranges now to increase their survivability. There's a lot of commentary out there about speed, the importance of speed, how much speed do you need? I would argue there can never be enough speed. There might be one or two occasions where you might say, I don't want any more speed, and they're probably, days that aren't going well. But in my career, even when I went from the, the 110 knot ground speed mindset to the 250 knot ground speed mindset, I still wanted more. I could reroute in tactical situations. It gave me so much tactical flexibility to have that kind of performance, whether I used it every day or not. This aircraft has such a wide envelope of performance. Sometimes people ask the question, well, what if I don't want to do that? Well, then don't. I mean, you can hover the aircraft, and it's an amazing hovering machine.
Yeah.
V-22 is an amazing hovering machine, very stable. But aircraft that can literally go very comfortably 0 speed, maneuver quite well. The false narrative of agility at the X being a problem for tilt rotors is just simply not true. We've had operators confirm that for us in V-22, and you take a sports car like V-280, we got all that. Now we provide that same level of agility, tactical flexibility, strategic flexibility, all the way through that envelope of performance, and that gives commanders at every level, tactical, operational, strategic, options that they never had before. And when you get it in the hands of the warfighter, they're going to figure out new ways to use this thing that nobody's conceived of yet.
And I'd even just add to that from an expanded role, in the future as the system matures. I think back to time in Afghanistan where, you would do 6 or 7 tail-to-tail transfers on a patient to be able to get them to the C-130, to be able to get them to launch stool. That's gone now with this capability. You can go direct from point of injury to that high-level care, and that's significantly a change in capability.
Yeah, I think people talk a lot about speed and how great it is to go fast, but you also have to look at it in terms of mission effectiveness, or how many missions you can execute in the same amount of time. That's something we don't talk about as much, but it's an incredibly important part of something like the V-280 that's got twice the speed and twice the range of the enduring fleet.
Yeah, I mean, the perfect example of that is deploying in a 53. We were good for probably 1 mission a night as part of a helicopter assault force. And then as the customer got used to flying in V-22s at the beginning of the night, and these are, I'm talking special operations type missions, but at the beginning of the night, they were already thinking about what follow-on missions they could get from information they would get off the target on the first mission, because we could do it in that period of darkness. And we could cover those distances if they were longer. And if they weren't longer, we could cover them so much faster that we could provide that second iteration of mission in the same period of darkness. And that's that's a very small example. When you start drawing that out over, some of the conventional challenges, movement of forces, intra-theater relocation, and again, standoff. You cannot combat the threat that we know is out there now with just some other counter threat. You have to, in some cases, be able to keep yourself out of those threat ranges. So, yeah, it's giant.
No, thanks, Frank. So you saw a transformation probably in yourself as you switched from helicopters to tilt rotors. How do you see that transformation going for the Army as they adapt to a higher speed technology for FLRAA?
Yeah, it's going to blow them away. They will make the same transition that everybody has. The Marine Corps, and it was a combined Marine Corps Air Force schoolhouse in New River. But Marine Corps saw it. I worked with those guys as we developed TTPs. We saw it on the Air Force side, in AFSOC, in the test community. I think the Navy's probably realizing it now that it's a game changer. Once you experience it and you start looking, you open that aperture, okay, there are things you never thought of before. You get it in the hands of the warfighters, and years of experience that the Army brings to this. And Army Aviation is just an excellent standardization, very disciplined force when it comes to training and execution, SOP, et cetera. I think they're going to realize very quickly that, yeah, I might have been worried how I was going to do this thing I always did. I want to now figure out how I'm going to do all these things I can do now that I couldn't do before. Mm-hmm. Carry that over into the Indo-Pacific area of operations. The Army has traditionally had to rely on other services to get them transported over longer distances, more challenging geographical expanses. And this now puts capability directly in the hands of the Army to control their own fate in that tactical to operational environment, and in some cases in that strategic, relocation of forces environment. I think they're really going to be able to do great things with that additional capability.
Thanks, Frank. So one of the things we try to do in the JMRTD program was create a collaboration with the Army that we hadn't seen in quite a while, and create a level of transparency with the Army as we went through the development and the flight test process. Don, can you talk a little bit about the transparency within our flight test operations and embedding the Army with Bell as we went through this journey with the V280 demonstrator?
Yeah, that's a great question. One of the things that has impressed me tremendously about our team is the transparency and the concept of teamwork. And that teamwork is not just within the flight test community or just within the engineers, but it's all of Bell and then including the Army as part of our team. And for me personally, that includes bringing in the Army test pilots that they've allowed to be part of our team. We trained them like we did each other ourselves. We made them part of the team, developing in the early days. We were all developing the checklist, the normal checklist, the emergency checklist. We were writing systems descriptions from a pilot perspective, and they were just part of the team. Mm-hmm. They were another pilot on the team, and that's been so rewarding because it helps bring that Army perspective into what we're doing, and it demonstrates to them, I hope, how open we are and how passionate we are about getting this right.
No, I appreciate that, Don. That's something I think the whole team is proud of, is how the Army and Bell have worked together and been transparent and collaborative throughout this design process. The Army's done something very unique, starting with JMRTD in the 2013-2014 timeframe, and developing these capabilities very far in advance so that when they get to the stage just prior to a program of record, they have a complete understanding of what the available technologies are capable of, and they've got that reduced risk heading into such a critical time, which is that essentially the acquisition and the program of record and developing that weapon system that's going to be the future long-range assault aircraft.
I would also add our commitment to that relationship. I mean, it is a theme throughout Bell. There's been a culture change at Bell, and I've watched it in the last 5 years. I know it started before then, about the way we approach this and our transparency with the customer, and also to include our Team Valor teammates on this. I mean, the level of collaboration throughout the JMRTD carried on over into CDNRR OTA is, we've gotten comments from other companies that, off the record type comments about how impressive that is, the relationship we've been able to establish and maintain as a collaborative, OEM.
I think it's to Don's point. It's because we care so much.
Yeah.
We have a deep passion for it. It's not at the end of the day, it's not about watching that aircraft roll out of the hangar and then we forget about it. That's not how we're thinking about it.
That's right.
So Becky, you talked a little bit about the systems integration lab, one of your true passions.
It really is.
Can you talk about what's difficult or what's not difficult about embarking on this MOSA journey and creating a new backbone for the aircraft that's going to be more accommodating to upgrades, in the future?
I think it's fun, first of all, right? So not having the arrogance to assume that we know what's going to be out there in 20 years. We understand the mission systems providers' technology roadmaps. We are certainly following along with it. It's all very cool stuff. But there's things that we need to plan on that, there's disruptors out there. We know that'll be coming in. So planning to build in autonomy, sensor fusion, what's going to happen with the avionics of the future with the helmet-mounted displays, and what can we learn with our flight controls control laws. We need to build in what meets the requirements or can fulfill the mission now by keeping it open enough and not pretending that we understand what fully is going to be there in 20 years. Because like Frank said, those phones are evolving faster than we can imagine. What is the air crew or someone who's not the air crew going to need to do with that weapon systems in the future? So it's more just keeping the aperture open, letting our imagination fly, and not locking things out.
Yeah, no, I agree. And as we were talking about the cell phones, I'm reminded of some of the shows we've been to, including previous AUSA events, where we showed how some of that technology trickled into the sustainment realm, and going from printed out tech pubs to what we've got now. And can you talk a little bit more about that, Craig?
Absolutely. So that comes back to innovation. Is we're trying new things. We're using that data. We're using that the straight engineering data. We're able to apply that to upgraded, manipulatable, just very high tech, very detailed publications that really enhance the maintainer's abilities, their skills. Allow fault isolation to occur a lot quicker, and really reduce that maintainer burden. You know, one of the goals for us is we have to be cognizant of when we innovate, it's got to fit. And so similar to the SIL, you know, we use the log lab, or establishing the log lab. And then our whole point is to make sure that these things that we produce, or these things that we show that capability on, are able to exist and interface in current systems that the Army uses. We've been able to demonstrate that. We're working collaboratively with the Army to bring that in and make sure we're going to be able to be supported. We don't want to be different. We have to be interoperable. We have to be integrated. And but at the same time, we shouldn't hold back on innovation. And you know, one thing that just kind of going back to Bell's changing culture that I really like about the IPS team as well is that we're a unique blend of people. You know, we have long-term Bell people with significant experience and database and log product data, but then they brought a bunch of us in from external, just out of the Army. So we have a mix of maintainers from different platforms, different services. And that really does allow us to, one, keep relevant and recent close relationships with our peers out there in the field, but really, two, have those conversations in detail about what works, what doesn't work, what do you need? You know, what do you need us to do, and allow us to do that for you. But at the end, to come back to it, is we have to integrate, we have to be interoperable.
Thanks, Craig. Autonomy. So another thing that the team did was they were challenged, the software team, develop an autonomous guidance computer, and in a short amount of time developed a software that would allow our pilots, our safety pilots, to go up in the aircraft, push a button, and allow the aircraft to take them through a sortie. So can you talk a little bit about that experience as well, the build-up and then the actual experience?
Sure, and it was a build-up approach like we do with anything, and it was very segmented, and we took a very disciplined approach to that as well. But when the actual test came, it was very odd, I got to tell you, to sit back, flip one switch, and not touch it again until it was back on the ground. And but it did exactly what we designed it to do. It did what the computer told it to do flawlessly from that initial flip of a switch to turning it off again back on the ground. So it was quite an accomplishment, and it was a pretty sad day for a pilot,
but think of the possibilities, maybe more than one aircraft. There's options out there, but it speaks to the stability of the aircraft too. Yeah. Along with the fly-by-wire. It was something they were able to accomplish in the time period they had.
Very proud of the team's ability to demonstrate that on the V280. Obviously, a huge part of that, again, is the software development and reliance upon the SIL, but really it's also the fly-by-wire technology within the V280 itself and the triplex redundancy of that system. So let's talk about survivability for a second. One of the unique things about the tilt rotor, particularly relative to helicopters, is the location of the engines, the gearboxes, and the props on this wing. And so in a crash situation, the wing is designed to shed away from the fuselage and move all of that, the rotating masses away from the occupants and maintain that cabin geometry to protect the passengers and the folks that are flying in the aircraft. Also, single engine capability is something that is pretty unique with the tilt rotor platform. I don't know, Frank or Don, if you can talk about what happens if you lose an engine in flight. What do you do at that point?
You got it?
go ahead.
So first of all, the tilt rotor by design with an interconnecting drive shaft that runs through the wing that connects both prop rotor gearboxes, basically. So one engine can drive both sides in the event of a single engine failure or a single engine emergency. Makes it a single engine event it's never a non-event. It's always going to get the attention of the pilot and the crew and passengers for sure, but it feels like a non-event if you are in cruise mode in a tilt rotor. And because of it's not infinitely configurable capability of the aircraft, even in lower speed flights, conversion mode and hover mode, it has very good single engine survivability characteristics. But if you lose single engine in cruise, and when you become a tilt rotor pilot, you immediately enjoy the comfort of flying around in cruise mode as much as you can. It's a non-event, unless you find yourself, maybe at high altitudes because you're making a long-range transit or something, in which case you're going to have to change your altitude to something lower that gives you a little bit more performance. It's not hard at all. Certainly not compared to relying on a rotary wing for lift is a little bit different experience. If you lose an engine, you have different concerns. I'll draw that real quickly over to, again, the over-water flying capability of a tilt rotor. I did 2 transatlantic flights, and it was a lot less stress than I ever could have imagined just doing a 3-hour over-water flight from, say, I don't know, Masira Island into the Arabian Sea at some point in time in my career. The survivability characteristics, not just for, crash, but just in general, single engine, the comfort you feel flying over water, the ability to change altitudes, the ability to reroute because range provides you the option to go around weather in some cases. All those things combined just contribute to the uniqueness of it.
If I could, I'm sorry, talk about, if that happens, even talk about our health awareness system, which is so important to the sustainment. Obviously, land, we should be able to tell the maintainer as quickly as possible what went wrong with that aircraft and get it back up and flying again.
Yeah, and that comes back, just to that rapid fault isolation, that real-time monitoring. How do we get that data off the aircraft? And, that really postures the maintenance team to be ready and prepared to make those rapid repairs, and really cuts down false isolation rates as well, when you're not pulling parts just to find the wrong one. So the HASS and the advantages of HASS, the biggest part now is we have those capabilities out there, but we don't have a useful way of using that data. And, so we have that inherent on Army aircraft today. It's not user-friendly, and we want to improve that. And we want to make sure we give that capability in a useful manner to the maintainer.
Keeping on the survivability theme a little bit longer, one of the things I think surprises people the most whether it's at the public demonstration we did or in demonstrations at our Flight Research Center in Arlington, Texas, is the acoustics and how quiet the tilt rotor is in cruise mode. Don, Frank, can you guys talk at all about that and some of the benefits that gives you as a pilot or as an operator?
Yeah, one of the ways that we have demonstrated that to folks is to do what we call a sneak pass. And we will get out of view from them and get to 200 knots and go right over their head, and they will not hear us until we are literally right over their head.
That's my favorite.
Yeah. So that really drives it home how quiet those rotors are. When we're in cruise mode, we slow them down. It makes them more efficient, of course, reduces the noise quite a bit. And then that allows us tactically to get very close to an LZ before we convert to land. So it over a conventional helicopter, a conventional rotor system, tail rotor system, so much quieter and so much easier to sneak up on the enemy or remain undetected acoustically.
And we have a lot of anecdotal evidence to back that up in V-22 and operations in Iraq and Afghanistan. Rotary wing aircraft are typically easy to track acoustically, and a lot of those missions happen at night, but an observer at an airfield will see a formation take off, and they'll start making phone calls to their family and friends, and quite often the element of surprise is lost. And this is proven in post-mission reflections gathering, whereas in tilt rotor, you could take off, and because, again, back to the performance, I mean, the range and the speed, you could actually take off opposite direction of the target you're going to, fly circuitously there. So not only do you confuse them on takeoff, but then as you're transiting, you're in a very quiet configuration. And I'd like to just hit that point one more time. It does not give off a loud acoustic signature comparable to, say, a MH-47 until you're within about a mile of that LZ. And that is, as far as getting the aircraft from its point of origin onto the target, you're not going to do better than that. It really makes a huge difference to keep the element of surprise out there.
So let's talk about another myth, which is the ability of a tilt rotor to go fast and low.
Yeah, it's
It's a myth.
It's a myth. It's a myth. I don't understand it because flying isn't really all that complicated when you look at it from the view of energy. And good pilots and aircrew look at it through that lens. How do I manage the energy I have, and how fast do I have to make decisions? And that changes with speed and altitude. So yeah, if you're going to fly at 250 knots and you're going to be low, you're going to be on your game. You're going to adjust your tactics, techniques, and procedures so you can compensate for obstacles that come at you at a whole different rate of speed. But if you want to fly even lower in a tilt rotor, then you need only to slow down to a speed and an energy state commensurate with the tactical objectives you have for that route, whether that's low and through the trees. You can do that. The aircraft will fly all day long, just like a helicopter too. So if there is a mission out there and MET-T drives you to needing to be NOE, I hear that term all the time, commonly misused, unfortunately, you can do it in a tilt rotor. And you do it with a pretty comfortable clearance of the spinning parts of that aircraft as well. You're not worried about putting something that's spinning down at tree level because there's nothing that does that. So I think the easy target people go after is width. Sure, it's wider. It's a different configuration. It's the configuration that most efficiently gets you, the only one that gets you that broad range of performance, but most efficiently gets you to higher speeds and greater ranges. It's still roughly the same footprint as a Black Hawk. It's just turned in a different orientation. But again, with all the technology out there, including, and I'd love to get back to the fly-by-wire and what that does for you over the life of a weapon system, you can come into objectives off axis if you need to, and that footprint and the orientation makes a difference. Because the technology you're dealing with today is much different than the technology they were dealing with 50, 60 years ago when those TTPs were developed, when it's really just the pilot, the crew chief, the pilots, the crew chiefs, 2 sticks and a map to get you into that hole at night. So it's a lot different. And I'd like to bring it back to the fly-by-wire thing because, again, I hesitate to use the word infinitely, but the aircraft is reconfigurable through its entire life cycle because of fly-by-wire capability. And then you pile on top of that all the other things we were talking about through MOSA and an easier path to upgrade without some of the complexities we face now when you change software and the ring out, et cetera. But I can't tell you over the course, the V-22, the flight control feel and the things I could do with the V-22 in 2005 when I started flying it versus 2016 when I had my last flight, it was like a whole different aircraft because of those regular upgrades and the input given by the crew. Like, we'd really like to be able to do this. Can you do that with flight control laws? Yes, we can do that. And through the vehicle management and flight control laws, you can transform the aircraft to keep that
everything
rate
he's
of
talking
change.
about is enabled by this fly-by-wire technology. Allowing the pilot workload to be lessened, allowing the aircraft to be inherently more survivable. So no matter what happens, if one of the triplex system, if we lose something, the air crew still doesn't have to significantly increase their workload. They can still go complete the mission. That in and of itself allows us to carry the mission equipment where it needs to go, do what we need to do. And then as Frank was saying, we learn more every day. How the aircraft is flown can allow us to tune the aircraft differently. So I think he is right, Frank's right, and the inherently configurable, because an assault versus a utility versus ISR, whatever we need to do, you need to control that aircraft differently, and we can tune that to the needs of what the end customer requires.
V-22, by the time I finished flying it, we were flying, you could fly hands-off tactical approaches. I mean, from the point of origin all the way low level to your objective, and it could land itself. Now, there are some things that are coming down the line in the future or starting to mature now that make that low level and obstacle avoidance and all those other considerations a little more executable. But you could do that. So taking that, even just the confidence of doing that and the demonstration of what fly-by-wire enables is one great example. And then, your starting point for this aircraft is so much further down the road. They're both tilt rotors, but it does start to become a little bit of an apples to oranges comparison.
Yeah, I can say early on in the design of the V-280, we leveraged a lot from the validated models and the test and the history that we had with the V-22. So when we came into V-280, we knew our models worked. We knew they were validated. We knew we were not doing extrapolations as much as we were just being guided by points that already existed and falling somewhere in between. So that was a huge leg up for us. and something that gave us, quite frankly, a ton of confidence as we went through the design phase that we'd be able to make commitments and execute on our commitments in flight test and demonstrate that capability on the timeline that we did.
Yeah. First generations are really tough. The fact that the starting point on this is it's really 550,000 hours of operational use of the technology in the most difficult environments. That's your starting point. And now you've taken all of that and you just, made something so much more advanced and credible, right out of the gate. I mean, it's going to work. We've proven it. In 3 years, over 200 flight hours, over 150 individual flights, able to, get the aircraft in the air on schedule, knock out all the key performance parameters, and then start looking for more. Literally asking, what else do you want to see? And then going and doing that. That's all the evidence you need that the benefits of V22 and those experiences have translated into making this, ready to go much quicker. I mean, JMR-TD is clear evidence that we're able to go faster because of that.
One of the first things I noticed coming on the team in 2014 was the mix of experience. We had quite a few engineers on the team who had XV15 and V22 and 609 experience, and we had young engineers, energetic, new ideas, new perspectives, and it was the melding of all these generational differences that the engineering team capitalized on to give us the V280.
No, that's a great point. I know I was a benefit of some of that transfer of knowledge, and I could see in a lot of the younger engineers as well, that transfer of knowledge from the folks that had lived through 1 or 2 design cycles with the tilt rotor, and now we've got a lot of experts on the team, and it's paying dividends, and we're continuing to do great things. With that, I'd like to thank my co-panelists here and my teammates. It's been an incredible honor working with this team as well as working with the Army on JMR-TD and in the CDNRR effort. And thank you very much to AUSA again and to our audience. Thanks.
It's kind of cool, the V280, huh?
Yeah, we all need one of those.
Oh, yeah, there you go. I'm fascinated with that stuff. I have no idea, no technological brain up here about that stuff, but it's so fascinating to listen to that. Oh my gosh.
Yeah, we can see what it's capable of doing. It's an amazing machine, and it's amazing.
Oh, it's unbelievable.
The development by Bell, et cetera. And I believe we've got Carl Coffman here with us, our great good friend. Good to see you, sir. How are you today?
I'm doing great. How are you guys doing?
Doing
Great.
fine, thanks.
Well, we really enjoyed that presentation, and we learned quite a bit. And I'm sure our audience did. Want to first off thank you and thank Bell for being our title sponsor for this 2-day event and for your support over the years, and in particular your support. We want to thank you very much for being part of this.
Absolutely. We appreciate you guys having us and the opportunity to talk about all the great work that we're doing here at Bell in support of the warfighter. I think we have a short period of time here for question and answer, I believe.
Yes, sir. So there are a couple of questions in the chat there for you to look at. I mean, I personally am very fascinated by this and would love to get your thoughts on, anything that you might add, any additional things that you thought, developments, et cetera, your personal take on this particular platform, which is amazing, and sort of where it came from and where it's going, where you guys see this going in the future.
Well, yeah, I appreciate the discussion. Let me start just with real quick. You heard a lot of the panelists discuss joint multi-role tech demonstration. There were, just with a lot of foresight from the joint services. It was a joint effort from the joint services to start thinking about vertical lift capabilities. Back in 2012 when this first started, and then we actually started building the aircraft in 2013. So there's a lot of foresight by the services there that we need to start looking at a different way of doing things, advanced technologies to get us to the mission requirements we were going to have in the future. So we're very fortunate to be selected to participate in that, and we've executed the joint multi-role tech demonstration. We've actually, had an extension on that to continue flight test and continue some development. So we've been very cooperative with the Army in that effort, and we're well down the path. Like Frank said in the panel, this purpose-built aircraft was designed initially starting as a baseline with all the experience that we had in V-22. And, we realized that if you're going to get to a long-range assault aircraft, it had to be a tilt rotor. That is the technology that best suits that mission. Bell, we are at Bell vertical lift experts. We understand that. We're certainly the tilt rotor experts. So we took a look at that, took a look at the Army requirements, or where the Army was trying to inform their requirements process for long-range assault, and took all those lessons learned off of V-22 in design and in operational context as well. So, that's where we are now. So to kind of get to the question too, real quick, the first question was, I believe somebody referred to the question of getting the government involved in operator influence on the design of this aircraft, and that is a great question. So we here at Bell have a core group of individuals on the staff that are, we have our engineers, and we have those here that are not engineers but operators. And the approach that we take at Bell is to take a Army requirement. Let's get operational experience in here, sit down, baseline with the engineers, and take that operational experience and then inform the engineering solutions. So we have a very good operating methodology here of aircraft design and development. We take operational experience, we inform those engineering designs, and it's a constant go between a back and forth between the operator and the engineer. So it's not the engineers developing a solution. It's the operators informing what the engineers are designing. And there's, they have a great deal of respect for each other here for what their individual capabilities are. And, they understand their roles in that. And it's just a joy to be a part of, and it's fun to watch as a former operator. Additionally, I would tell you that the Army and the Army Futures Command, the way they're setting up their modernization efforts, and getting at these, getting at the process of informing requirements, they have what they call soldier touch points. So what they do is they bring operators, the Army, through Army Futures Command, schedules operators to come out and spend time with us if we so desire. And we at Bell did so desire, right? So we had our first test pilot, Army test pilot, come out. We were less than 10 hours of flight time on the aircraft, and we were comfortable enough with what we were doing, and the Army was comfortable enough with what we were doing, that we had our first Army test pilot fly the aircraft before we were even 10 hours into the test flight program. Since then, we've had 15 Army test pilot flights, test flights that the Army pilots have been involved in. And these are not, and it was with 5 different Army test pilots. These are not test flights or demo flights. These are actual test flights. So we put Army test pilots in the aircraft and put them to work, hitting KPPs and hitting test points. Additionally, the Army Futures Command afforded us the opportunity to interface with maintainers. So we sent a group of Army maintainers. The bottom line is if you want to know what's wrong with a product or what the challenge is with the product, you ask a soldier or a Marine or a young airman, right? Because he will give you the facts. They are sometimes very blunt, and we appreciate that. So we had a group of maintainers come out, work in and around the aircraft for a couple of days, and they gave us tremendous feedback on the accessibility of certain components, challenges with some of the maintenance requirements that they have now, and they certainly offered their feedback. And we also recognize clearly that this air vehicle, which will be a weapon system, is not just about aviators or aviation maintainers. The real customer and the real focus of this aircraft is the infantryman. So we also had the opportunity. So we refer to that kind of as the back end of the aircraft, is the customer end of the aircraft. We had the opportunity for the CFT to send an infantry squad from the 101st Airborne Division out here to Arlington. Now, the 101st Airborne Division, for those of you that may not be familiar, this is the Army's premier air assault force, or what will be the premier long-range assault force. So we had an infantry squad come out, the young squad leader and his soldiers climbed in around the aircraft and gave us a great deal of feedback on seating, seat widths, configuration, step up heights, step down heights, moving in and out of the aircraft with the soldier basic load and weapons. So we got a tremendous amount of feedback from the Army that will continue to inform the requirements as we evolve out of the joint multi-role tech demonstration and into a program of record.
Well, I just have to say personally, as someone who's been involved in rapid product development, I'm an OpEx guy. Your guys focus on voice of the customer, having this interactive, iterative process of improvement and being brave about having an open kimono, showing all your wares and truly partnering with the customer is really impressive.
Well, that's how you capitalize on engineer time and your internal research and development dollars as well. I mean, this was a joint effort between us and the Army initially. Primarily, we invested. Certainly, the Army invested, and without that, just like you said in the rapid prototyping, without that cooperative openness with the customer, you can't really capitalize on your IRAD investment unless you have that interface between the customer. There's no reason for us to be out spending internal IRAD dollars or the Army spending S&T dollars working a problem or working a solution to a problem that somebody doesn't have, right? We want to be working solutions to the problems that you do have. So that just gets us a bigger return. That gets us and the customer a bigger return on their investment, not just in IRAD dollars, but in engineering time spent on developing these solutions as well.
Okay. And I imagine that has impacted your view of the future. When you're talking to them, you're saying, okay, this is a Ferrari. I mean, this is a beautiful machine. Okay, thing's beautiful, but how could we make it better? Could we make it more like a truck? Does it need to have longer range? Does it need more speed? Does it need more, interoperability? Is it the stealthiness of it? I imagine you have gotten a lot of input from them on what the future of this the system is going to be.
Absolutely. So there's a lot of growth built into this. Aircraft as well. The Army refers a lot, and all services now have been referring a lot to common or to open architectures, open backbones, so to speak, digital backbones in the aircraft. It's important as the threat evolves that you're capable of rapidly upgrading and adding additional capability onto the aircraft. Very simply, we use terms like the ability to integrate something into your home computer today, or like an iPhone where you can just download an app and upgrade your iOS system. That's where the services are going. It's a significant cost savings. And not only is it a cost savings, it's a time, it saves you a significant amount of time. At the rate the threat is achieving additional aircraft or additional capability, trying to stay ahead of us in terms of parity or achieving overmatch, you have to be able to rapidly integrate new capability in the aircraft or you're just irrelevant. So that's what we're after here. We're developing a common open digital backbone for this aircraft. You heard Becky talk about it a little bit on the panel. Becky's crew and the guys in the systems integration labs are developing this backbone. So what we want to do is we want to prevent what the defense industry and what the U.S. government refers to as vendor lock, so to speak. We want to be able to rapidly upgrade capabilities in this aircraft, because if you can't do that, then you just become irrelevant and you put the guys out there in the fight at risk.
Fantastic comments. I think we've got maybe a minute or two left. If there's a question there you see in chat that you'd like to answer, I of course could ask you a dozen. So I'll spend the next hour with you if you'll let me. I'd just like for you to share whatever key takeaways you think that the business community, the commercial side, all of our listeners should need to hear about this system and the future of it, and how and sort of we can be in support and how we can partner together to help you accomplish your mission, which is helping our military accomplish its.
Well, and maybe I'll just start with that at the top in a very broad level, if that's okay, real quickly. Look, the Army has a requirement. All the joint services have a requirement to modernize. That is without question. Every service will be required in the future to participate in either deterring a conflict or winning a conflict across the globe. This is, you hear a lot about Indo-PACOM. This is not only an Indo-PACOM challenge. Those challenges reside in Eastern Europe, in the Pacific, in the Arctic. They are going to be a national security challenge globally. What we're offering with our FEL solutions, what we're trying to get to is allowing the COCOM commanders the ability for, we've talked a lot about agility, to be strategically agile as well as tactically agile. You have got to have a capability as the premier ground force, that's the Army's mission, is the premier Army ground force to maneuver over extended ranges at greater speeds now. It is no longer, we're not operating in the same battle space we were previously. The threat capabilities are pushing us out further. They're requiring us to develop and field systems, vertical lift systems with increased speeds and ranges. The military, the joint force as a whole is going to have a maneuver space, a geographic space, and a reaction time challenge. Speed and range are the answers to those challenges. That's why the two FEL aircraft that Bell's in the process of working right now, we're building the Flara aircraft right now. It's purpose built for that Flara mission. We don't take a technology and try to wedge it into being a solution. We develop a solution up front. And we understand that the Army has a requirement to modernize. The Marine Corps, the Air Force, the Navy will all have a requirement to modernize. And we are here to offer solutions across the board in support of that modernization. And we understand who the customer is. We understand what's important to them from an operator experience, and we're engineering solutions to get at those requirements.
Well, you guys are doing fantastic work. I want to thank you for your time today. Thank you for Bell's support of our program. Hope you have a great day, and we look forward to seeing you a little further down the road, sir.
Yes, sir. Thank you.
Thank you very much. They do great work.
They sure do. It's again, I don't mean to show my ignorance, but it's fascinating to listen to them and just the whole plan that they have of how it all pieces together.
Yeah, so they're very thoughtful about that. And
Yeah, it's
like
so
I say,
obvious.
like
So
someone said
obvious.
yesterday, I'm willing to bet on our team.
Mhm.
I'm willing to bet on teams like groups like this that are humble, don't think they know everything,
Mhm.
ask the customer, are willing to fail quickly and often,
Mhm.
break it, fix it, whatever they have to do, have no sacred cows. If we have to start all over, we're not going to try to shove our technology into something,
Right.
reinvent the wheel, start with a clean slate, clean sheet, as Style said. That mindset is the winning mindset, and that's what Bell's culture and leadership have done. And I think that's clearly why they're the leader in that particular
So
field.
just figuring out how to get it right by doing it right.
Yeah.
And they really, I
Yeah.
was most impressed.